So in the last class, we discussed about something related to the product design and manufacturing, a detailed concept where what we understood was what is the definition of the product design and what is the definition of the manufacturing and how the product starts and it ends in getting the product into the market. That is, the idea will be generated and next the design will be carried out, and after the designing process, the manufacturing stage where the parts will be manufactured, assembled, and then a product, whatever the product that has been developed, will be sell into the market. So that is the whole concept of product design and manufacturing, which we discussed in the last class. And one of the example I took, how the product design, the evolution of how the product design took place. Initially, the product design era started with craft-based era. So that is what where the parts were made by hand and skilled artisans. So the design and productions were integrated in that. The customization was high, but scalability was low. So there was some constraints or some disadvantage in the craft-based era, due to which the emergence of engineering design era took place in after post-industrial revolution. So where the in the engineering design era, a separation of design and manufacturing process were being developed. So introduction of standardization and interchangeable parts, design became systematic, involving calculations, drawings, and specifications. Rise of engineering disciplines like different departments will come into picture in engineering design era. And I took an example of handmade wooden chair for the craft-based system, where artisan usually he designs and he prepare the parts, where a combination of design and manufacturing is been there in this particular craft-based era. Whereas when it comes to the engineering design era, where you can come across a different department, like designing department is something separate and the production department is something different, where because in designing department only a conceptualization of the part, how it has to be designed, and detailed design of the part, what are the features that should be there in that particular design, all those things will be focused on the designing stage. So I gave an example of smartphone in that, where a smartphone will be designed and its specification is been represented like its screen size, battery capacity, camera specification, all the detailed drawings will be come into picture in this particular designing stage. Whereas in production stage, the smartphone will be what are the components that will come into picture, like material selection. Initially the material selection plays a very important role, like there are different parts like body part, it needs to be prepared by aluminum material, and the glass cannot be prepared by metal, right? So a glass screen cannot be prepared by metal parts, so a glass will be chosen as the material. So though material selection plays a very important role, and the different production methods which has to be followed in preparing different parts, like CNC machining will be utilized for the frames, injection moldings will be used for the plastic parts, and other things will be coming to picture, and the assembly and quality control will be followed by the production of the parts. So that is what I have been shown here. And the types of product design were being discussed, like by design by evolution is one of the thing, and design by innovation is another type. So what is the difference between these two means? When we consider the design by evolution, I have given an example of this bicycle, where you can just notice the first picture of the bicycle indicates the starting development of bicycle which come into market in 1800s or 1900s. So as we come in today's year, like 2020 or 2026, the most of the features remain the same: the wheels, spokes, the seating arrangement, the handles. So only light changes in the aesthetic has been you can notice in this particular design, the upgraded version of the bicycle. So that is what we call it as design by evolutions, where you just where the gradual improvement of an existing design will come into picture. The bicycle, as I've been given an example, where a gradual improvement has been taken, rather than a sudden innovation which has to be taken place. So when it comes to the design by innovation, I've given an example of this two process called subtractive manufacturing and additive manufacturing. And in this particular process, design by innovation, where a design of the part, referring to creating a completely new design approach based on scientific discoveries or advanced technology rather than improving existing design, means whatever the part that you are going to prepare, the technique in which you're going to focus is completely different in the design by innovation method. And the best example is a 3D printing, which I have been given here. So because whatever the parts that are going to be manufactured is completely a different process that you're going to implement, where because additive manufacturing is where the parts will be built layer by layer, whereas in the subtractive manufacturing, the parts, whatever the parts that you need to prepare, so a complete raw block will be taken, and the whatever the material will be there, excess material, that will be removed. So it is a subtractive manufacturing process. So a changeover has been taken place completely by subtractive manufacturing to additive manufacturing. So this is what we call it as a complete innovation way of design. So these are the two types of product design which we have been discussed in the last class, and also we discussed about the production consumption cycles. So whatever the part that you are going to prepare, whatever the product that you are going to prepare, so it follows a production consumption cycle. So where the important thing which you need to focus is the four steps, that is the production, the distribution, the consumption, and the recovery stage. So whatever the product you consider, it follows these four stages. So in the whatever the things that will be followed in the production means creating the goods or service using raw material, energy, and labor. So example I've given, a manufacturing car factory where using steel, electronics, and assembly process, the complete car will be manufactured. So after the manufacturing process, the product needs to be sold. So a distribution process will come into picture, where the parts in the cars that is been prepared, it needs to be transported from one place to another, and it has to be delivered to the consumers. So the shipping cars from factories to dealerships is one of the step. And after the cars has been sent to the factories or dealerships, the dealers will sell the goods to the end customers. So end user is what a common people who buys the car. So that is the consumption stage. And the last one is the recovery stage. After the product has been utilized completely, it has to be scrapped, right? So whatever the collecting and recycling waste we do, we call it as a recovery stage. So where the products will be recycled so that it does not affect the environmental conditions. So that is what I have given here: recycling old car parts and other things. So different categories of information used in the production consumption cycle. So that is, the information plays a very important factor in production consumption cycle, because whatever the information is there, that will be flowed in the all the different stages of production, distribution, consumption, and recovery. If you consider a production stage, you require information. What type of information is required for you? It is a technical and specification information is required. When it comes to the distribution, a logistic information is required. And in the consumption, the user and latent information is needed. And in the recovery, recycling, and material composition information is needed. So we will go one by one. In production stage, that is, you require a technical and specification information. During this production stage, engineer depends on detailed information of the material, components, and environmental conditions to ensure the product can be manufactured correctly. And when it comes to the specification information, what type of material that you're going to use, whether the machinability is been can be done using those materials, the process parameters selections needs to be selected, so that whatever the parts that you're going to prepare, that will be performed with a safe and efficiently. So the cost and resources information also plays an important role in the production stage. So together, all this technical and specification information yields high quality, reliable, and consistent manufacturing. When it comes to the distribution stage, the logistics information. So during this distribution stage, companies relies on logistic information such as demands levels, transportation routes, distances, and warehouse conditions. So why the demand levels is very important, because it gives a clear picture that what are the components that needs to be manufactured, what is the demand that the customer is expecting for the particular time period, right? So company has to develop the product, how much product it needs to be developed. So based upon the demand level, that information, the company starts to developing the product. So information on transport capacity and scheduling will be followed with it, because what are the components, what are the products that will come out from the factory that needs to be transported. So what is the capacity, how much vehicles has to be arranged, so that the efficient planning and cost reduction will takes place. Accurate inventory and storage data helps prevent delays, shortages, and excess stock. So whatever the inventories and the necessary raw material that is required to prepare the product, that will be stored in a particular place, so that no delays will happen, so no shortages will happen. Or if you have borrow, I mean, if you have brought more inventories, so that will leads to the excess stocks, that will what damage, mean that will make the company loss, or because due to the storage capacity will be increased, and maintenance will be increased, so that will add up to the indirect cost, where the company will be in loss. So due to which all this logistic information needs to be recorded, and it has to be timely managed. So understanding environmental or handling requirements ensure product safety during transit, so that it does not get damaged, degraded, or become unsafe while being moved from one place to another. So all these things will be come under logistic information. So consumption stage, user and latent information. So this is the stage where the customer uses the product, where he actually interact with the product in real life conditions. So while he interact with the real life condition, he come to know some valuable inputs, which is what we call it as latent information, where some of the information will be hidden issues that only become visible after deep analysis, after deep usage of the product. All those things, the user gives the feedback. The phone, if you consider a phone, it needs to be charged for it needs to be give a battery life of 2 to 3 days span. But while usage, it is giving only 1 day of complete battery backup. Means that is the issues that is coming after the usage of the product. So all these things, user, what are the user gives on the product reviews, we call it as the users and latent informations. And some of the complaints that is being logged by the customer service logs, and all those things will add up to the information in consumption stage. Recovery stage, as I told, after the product has been utilized completely, it needs to be discarded. So what is the information that is necessary for the uh, company to discard the product is, first initially, the what is the material that is being utilized in the product. So how the material behaves after the long-term use or exposure in the environment. So knowledge of recyclability and degradation helps to determine whether the material can be reused, or it has to be remanufactured, or it must be safely disposed. So there are three things which you need to be focused on the recovery stage, because whatever the product that has been expired, some of the parts can be reused, and the product can be remanufactured, or if we cannot able to use any of the parts, it needs to be disposed. So the all these things has to be considered while in recovery stage. So information about disassembly technique needs to be followed without damaging the valuable parts or creating waste. So the creating waste will leads to the or wastage of the product. So environmental and sustainability data has to be followed. So recycling and recovery information are the two parameters that needs to be concerned to develop a safer, greener, and more sustainable products in future design cycles. So, example I've given one mobile phone packaging, where the company learns from sustainability analysis that their packaging uses non-recyclable foam. So, initially, if you're using non-recyclable foam, it will be affect the environment. So, switch on to the 100% recyclable foam. So that will leads to the what eco-friendly, and which will follow with the environmental regulations. So all these things will be considered in the recovery stage. A design process. So whatever the product that will come into the market, so it can be in the form of three ways. One is the creating a new product. A completely new product will be come into the market. That is, engineer may start from scratch to design. What is the role of the engineer? He needs to design the process. So how he starts from scratch, he is going to design a complete new product that never existed before. So example I given, designing a new drone model for delivery services. So this is a completely new concept or new product that the designer develops. And another one is adapting an existing product for a new application. Sometimes an existing product is modified or adjusted so that it can be used in a different situation or industries. So example, using a vehicle engine design and adapting it for a generator setup. So all the engine, whatever the engine that has been utilized in the brief before product, that will be taken and it will be utilized for the generator setup. So that comes under the adapting an existing product for a new application. So third one is improving an existing product. So whatever the product is there already, which is being there, you are going to improve it by refining its parameters or specifications, so the betterment of the product will be developed, so which will be safer, cheaper, or easier to use. Example, updating a smartphone camera or increasing the battery life. So whatever the phone is there, right? So you're going to improve its parameters. By improving what are the parameters, the battery life you're going to improve, or the smartphone camera that you are going to improve. So all these things will be considered in the design process. Product realization process. So a product realization process is nothing but a complete journey of a product, which is turning an idea into a final workable product. We call it as a product realization process. So it follows a sequence, well-structured stages from designing, validating, and ready for real-world use. So the product design realization process is completely what from initial scratch of a design to the component which is being manufactured. So from starting to end, whatever the stages that will come into picture, we call it as the product realization process. But when it comes to the product design realization process, we focus only on the design compartment design. So what are the design stages that will come into picture? Conceptual design will come into picture. You're going to validate the design. How you're going to validate the design? By analyzing the product which you have been developed. So after analyzing, you're going to prepare one prototype and you're going to test on that. So after all this thing, you're going to say that yes, this product is worth to manufacture, so which will yield a good result in the product. So after that, then only the manufacturing stage will come into picture. So up to the prototype development, we call it as a product design realization process. So first one, a problem definition. The problem definition is a part of the product design realization process, because initially you don't know what is the problem definition. So you need to define what the need of the user or the customers. So the process begins with a clear definition of a problem. At this stage, the initial idea, the initial The initial idea is refined into a specific, concise, and well-structured problem statement. This includes understanding user needs, constraints, objectives, and the context in which the product will function. A properly defined problem provides direction for all the subsequent design activities. So initially, you're defining the problem, and that problem will be taken into the engineering design stage, where in the engineering design stage, initial starting phase is what the conceptual design stage. So you're going to do number of iteratives, concepts you're going to develop, and based upon that planning, modeling, selecting the material, considering function, aesthetic, economic requirements, all those things will be considered, and you're going to prepare a number of iterative conceptual design. In that, you're going to choose any one of the design, that is what, to produce multiple feasible design option before narrowing them down. So that stage we call it as a creative process. In creative process, you're brainstorming different possible solutions that will come into picture, and listing out the iterative 1 to 10, and then you are going to select one particular best design which you are going to be utilized for further stages. Next, after that design, it will be analyzed. So analytical process will come into picture, where the concept generated during the creative process are evaluated using engineering analysis. So this includes developing models or prototypes, performing calculations and simulations, comparing alternative, checking feasibility, cost, durability, safety, and performance. This ensures that the selected design solution meets the expected functional requirements. So that is what I discussed here. The product design realization process. So up to the prototype development. So that is what I have shown here, developing models or prototypes. So up to there, you're going to do the design stage, where you're going to perform some calculations and simulations, and you come to a conclusion that this design is feasible, and this ensures that the selected design solution meets the expected functional requirement. And then only you're going to go with the manufacturing step. Before that, you're going to finally check the creative and analytical process. So this ensures that the chosen design fully satisfy all basic requirements, standards, safety norms, and performance criteria. Only after passing this stage is the product considered ready for manufacturing or practical use. So as I told, a problem definition you have been defined. After problem definition, you're going to go with engineering design, and then in the engineering design, it has been divided into two stages. One is creative process. The complete generative ideas and concepts will be developed, and it will be narrowed down into one particular concept, and that concept will be analyzed. How it will be analyzed? By preparing one prototype and performing some calculations and simulations on that, and then you're going to say that yes, this design meets its standards, and then finally you're going to check the check the product. Before the manufacturing, the prototype which you are going to which you have manufactured, that will be checked. One of the example I've given here is a portable Bluetooth speaker. So while traveling or during a small gathering, a portable Bluetooth speaker allows user to play music loudly and clearly without carrying large audio system. So after the creative process and analytical process, the ultimate check is performed. So what is the ultimate check that will be performed? Means performance requirements. So does the speaker deliver the expected sound output? Is the Bluetooth range at least 10 meters without the interruption? Does the device meet electrical safety standards? Does the charging port function properly with standard chargers? So all these things are the specifications which are going to be checked practically when the product is being prepared. And then if all the condition is been satisfied, then the approval will be given for manufacturing the mass number of products that will be released to the market. If it fails in any one of the criteria, then the design must be modified, and it needs to be retested until all requirements are satisfied. So these are the all the stage that will be considered in product design realization process. Product realization process is what, where you're going to add the manufacturing stage as well as the logistic, where the product will be delivered to the customer place. So these are the two extra thing that will be added up in the product realization process, so that we are going to check here. Okay, so this to manufacturing and logistic will come under the this product realization process, apart from the product design realization process. So some of the terminologies which you need to be understood in product design and manufacturing here are industrial design, aesthetic design, manufacturing, logistics. So what do you mean by industrial design? What is the importance of the industrial design? So industrial design is mainly focusing on the form and function of a product. So form is what the visual appearance, and function is what how the performance of the product is doing is what it has been considered. So the industrial design is concentrating on both the visual appearance, that is the aesthetic look, what we call it as visual appearance, aesthetic look, as well as the functionality of the product. All these two will be considered in the industrial design. So its main purpose is to enhance user satisfaction and create a strong connection between the product and the user. So industrial design works around the technical part designed by engineer and make sure that the shape, form, and usability fit properly with the technical system. That means in the engineering design, whatever the technical performance that the product needs to be performed, that will be prepared in the engineering design. And what does the industrial designer will do is he will work on the engineering design, whatever the engineering design that has been prepared on that he is going to be worked. So how he will be going to work means, I've given one example which clearly indicates that a electrical kettle, as you all know that electrical kettle is one of the product. So engineering design will come into picture. First, he consider the technical performance. He tests the technical performance. That is the functionality of the kettle he will be going to carry out. So what he performs, he first focus on how fast the water heats. What is the efficiency of the heating element? Thermal insulation to prevent heat loss, safety cutoff when water boils, durability of the internal components, energy consumptions. This performance is scientific, measurable, and technical. So all these things will be considered in the engineering design. And the industrial design, how he think of, he focus on how the kettle works for the user in daily life. That means the easy way in which the user can use those kettle. So by giving comfortable handle grip. So it is an extra addition thing, right? So a kettle, you are initially develop the heater where it will boil the water, but when it comes to the user for using in a daily life, he needs some handle easily gripping the giving the grip for in the handle will easily or comfortably he can lift the kettle and he can use it. He can pour the water and he can just easily giving a proper on and off switch, so that when the water get heats, you'll just switch off the button, and if we needs to start, you'll just switch on the button. So that flexibility, giving the flexibility for easy usage of the product will come under industrial design. So this is a technical performance where the engineer design will focus. In the industrial design, easy to pour the design, pour the water, visible water level indication, attractive shape and color and overall design. So as I told, attractive shape, color and overall design, it is mainly focusing on the aesthetic view of the kettle, and easy to convenient lid opening, intuitive placement of the on and off switch. So this performance is about ease of use, comfort, and appearance, not internal technical efficiency. So these are the two things which you need to have a difference between the engineering design and the industrial design. So aesthetic design, as I told, it's a part of the industrial design where it is mainly focusing on the beautification of the product. So most of the companies like Apple, Samsung, automobile brands, home appliances, sports equipments, all are focusing on the heavily depending on the aesthetic appeal. So why they are focusing on means that makes the product attractive, usable, and emotionally appealing. So the customer will buy the product more and more. So manufacturing, as the term manufacturing is concerned, where it converts the raw material into a finished product. So that will be ready for the use. Example, converting steel into a car body, turning plastic pellets into a bottle, assembling parts into a smartphone. So all the things will come under the manufacturing. So logistics, it deals with the movement and positioning of the resources at the right place and at the right time. So logistic includes planning and acquiring material, storage and warehousing, distribution of the goods, from one place to another, movement of information, energy and personnel, delivery of products from factory to customer. So all these things will come into picture. So as I told, the product realization process is completely a broader one, right? So it can be called as product development cycle. So what are the stages that will come into picture? The idea will be there, and to that idea, the problem definition will pitch into come into picture, because due to some concept, whatever the concept there, what is the need? Usually the need, a need of the customer. What is the need of the customer? Based upon that, a problem will be defined. So and then the to the problem definition, a design team will work on to design the conceptual design, and get a one particular design which is feasible for the manufacturing process, and the design will be tested by the prototype which is being manufactured, and the simulation, all this will be carried out and it will be tested. And then if it is feasible, then the manufacturing of that product will be carried out, and finally the delivery of the product to the customer. So all the stages will be followed in the product realization process. The features of effective product development. So when you're going to say the product which has been developed is effective, it has been categorized on the product quality, the product cost, and the product development time. So these are some of the features of the effective product development. So when it comes to the product quality, the product quality describes how the goods that is being prepared, which whether it is meeting the customer expectation or not. High quality product increases customer satisfaction. So market share and the price customers are willing to pay. Product quality check is done by checking whether the product is reliable. Can customer trust the product? A reliable product reduces complaints and increases trust. So that means whatever the product that is being going to be uh, um, prepared, it should be of high quality. If high quality means the customer expectation you are going to meet, and the market share will be increases, and the price of that particular product will increase, and the company will get the profit. If the quality is not good, then the product won't be survive in the market, and a huge loss of the product, I mean huge loss will going to expect to the company. When it comes to the product cost, the product cost refers to the amount of money required to manufacture the product. It includes the material cost, labor cost, manufacturing expenses, testing cost, overhead cost, because cost is the one which decides what is the amount of selling price that I need to keep for the particular product. The profit earned per product will depend upon the what is the cost that you're going to kept that you are being kept for that particular products, whether the company can compete in the market, how much money can be gained at a particular sales volume. A well controlled cost ensures that the product is affordable, profitable, and competitive, because whatever the cost that you're going to fix, that needs to be properly thought, and then it needs to be fixed, because there are a number of products of similarities will be coming into the market by the different competitors. So the product cost decides the what the number of product that will be sold in the market. The product development requires both time and money. So apart from the cost, the quality, the time that is been plays a very important crucial factor in selling the product, because whatever the product that will come into the market, so the managing cost and time effectively is essential for successful development. The cost of product development will be involved with the number of process, that is how many number of people going to be involved in developing a product. So for smaller product development, number of people required is very less. So if the duration of the product is very high, then the time of the development of the product will increases, and the indirectly it will increases the development of the product cost, like by giving the salaries, materials, testing, equipment usage, all will come into picture, and it will increases the cost of the project. So type of product which you're going to develop, as I told, if it is a simple project means the time required will be less. If it is a more time duration project means the cost will be high. So that trade-off has to be made between the cost and time duration. So direct cost, indirect cost, all this will come into picture. So what is the optimum duration in which the product you're going to build plays a very important role. So this is the best time to complete the project when the total cost is minimum. So what is the total cost? Total cost is nothing but the indirect cost as well as the direct cost. So what do you mean by direct cost? So direct cost includes salaries of the engineers, designers, technicians, testing, etc. If you complete the project very quickly, you need more manpower, overtime, rapid prototyping, high direct cost. If the project takes longer, the workload spreads out, direct cost decreases. So that is why the direct cost line slope downwards. You can just see in the particular diagram that the direct cost is dropping out based upon the time duration in which you can just see as the time duration increases, the direct cost reduces. And also the indirect cost, you can just see here, it is increasing as the time duration is increasing. So that is what you have to manage. The time duration in which the product needs to be completed has to be managed. What do you mean by indirect cost? Indirect cost is nothing but a delay in market entry, loss of sales opportunities, overheads, management cost, inflation in material cost. If the project takes too long, this indirect cost rises. So all those thing parameters needs to be considered to get a best product over the time. That is the optimal duration has to be properly chosen, and the product needs to be prepared, and it needs to be uh, sold in the market. So what are the major concerns in product development? So the trade-off, as I was speaking about the trade-off means that what do you mean by trade-off means choosing a best desirable features between the two or more multiple features that is been available. So which one you're going to choose? If you choose one means another parameter will get worsened. So that trade-off has to be thought of by a design engineer, and recognizing, evaluating, and all those things has to be carried out. So to choose the most of the desirable features in a product, because all the features cannot be what at the ultimate level. So some of the features needs to be improved, and some of the features has to be kept at the middle version, and it has to be managed. So that trade-off has to be played in a safer zone. Example, making an aeroplane lighter reduces fuel consumption and improves performance, but using lighter material increases manufacturing costs. So these are the the parameters that needs to be uh, mm, chosen in a better way, so that the product which you are going to develop will meets the required standards. So another one is dynamics. The product must be designed to adapt to continuous changes in technologies, market trends, competitors, and customer preference. So whatever the product that you're going to release into the market, a continuous changes in the technology will happen. So if you develop the product which is outdated, then what is the use? So the dynamics nature needs to be analyzed, and the product needs to be developed, and it has to be uh, sent to the market for the successful of the product sales. Time pressure, as I told, there is always a hurry to develop and release the product quickly. Why it is to be developed and release the product quickly? So the competition will be high. So team often have to make decision even when they don't have all that information. So if the time will be increased, what happens? The whatever the product that you're going to develop, it becomes outdated. So you have to be in the race. When you are in the race, then only the product will be what it will be there in the market, and you will get the very good yield of that product by getting the more profit. So economics, the company must make sure that the product is affordable to build and can earn enough profit after being sold. Satisfaction of societal and individual needs, the product must make people's lives easier and also follow rules about safety, health and environment, and social responsibility. Team diversity, because whatever the product you are going to develop, different skills people's that is been required. So a diverse team is very much necessary in product development. team spirit, the team members who are working in the particular product, they must be what having a team spirit, that is they needs to be motivated, work well together, help each others, cooperate to successfully create the product. So these are some of the major concern that needs to be uh, followed in the product development. So trade-off, dynamics, time pressure, economics, satisfaction of societal and individual needs, team diversity, team spirit, all will come into picture. The process of product development. So some of the important concepts, just concepts that is being uh, connected with the process of product development. So one is the capital circulations or the production turn. There are a number of things which have been listed here: capital circulation or the production turn, manufacturing capability, mass production, interchangeability, product life cycle, the S curve of the technology growth cycle, simultaneous or concurrent engineering, design for manufacturing, engineering, problem solving process. So all are some of the terms which is interlinked in product development process. So first we will go with capital circulations or the production turn. So what do you mean by capital circulation? It describes the complete cycle of money which is going to be flow in a manufacturing enterprises from initial investment to profit generation and reinvestment. So it explains how capital is put into production, converted into products, sold in the market and returned as revenues. So this is the flow chart which you can just notice here. The chart which clearly indicates that firms is nothing but the companies. So what does the company do? It prepares the product and it sells the goods and services. So it will sells the goods and services to the market. So in return, what the company will get, it will get the revenues. So it sells the goods and services, and in return it will get the revenue. Where it will going to sell the goods? In the market. And who is the buyer? The household people. The customers are the buyer. Firms will sell and the household people will buy the product. And that is what the another arrow mark which clearly indicates that household people will take up the goods and services, and in return they will spend the money on the goods. That will be what the revenue generation for the firms. And then the household, the people who's having the land, the who's having the laborer, the workers, all those peoples, the customers, all those peoples will be called as household. They will give what the market for factory of production. That means for a factory to run, they require some space. Capital investment needs to be there, right? So some of the people will give the loan, some of them will work as the laborer, some of them will give the land. So all those things will be taken by the firms. The firms will buy those features, and in turn they will get the income. The household people will get the income. Household people is nothing but what? The people who gives some uh, uh, who gives the laborers the land, who's having the property. All those will come under the household people, where they will take the income by giving the laborer land and capital to the factory or the production unit. And then those will become as the input, the laborer, land and capital, that will become the input for the company. And the company will give the wages, rent and profit to the household people. So household will sell those things and the firms will buy this. So by doing this, the firms needs to give some rent, or whatever the profit the product has been got, some profit needs to be given, because they have given some land, the initial loans, all those things needs to be cleared, right? So from the profit, whatever the profit they have got, from that some profit they will clear those needs, initial needs that is been required, which is been given by the household people. So these are the flow diagram which you can just consider that the circulation of the capital which is going on. That is what it means. The capital means what? The complete money flow which is going to takes place in this production turn, right? Next, manufacturing capability. The manufacturing capability defines what can and cannot be produced in a given facility. It ensures efficiency, but also imposes boundaries based on design, technology, and scales. Manufacturing capability refers to the limitations and strength of a manufacturing unit in terms of what products it can produce. These limitations are shaped by physical, technological, and operational factors. So we can just concentrate on the key constraints, so size and weight capacity. So because each plant or machine can only handle materials or product within a certain size and weight range. So this is the capability in which the machine can handle. So if you go with a higher weight and size, that machine can't handle it. So therefore, a small CNC machine cannot process large aircraft components. So that is one of the uh, limitation of that particular machine. So technology availability, the type of technology installed determines what raw materials can be processed. Example, steel rolling mill cannot process plastic. So that is one of the limitations. So the capability of that particular technology in which the company has been using will be having some restriction. Only the steel rolling mill, uh, a steel rolling mill cannot process plastic. That is what one of the technology which availability of the technology in that particular company. Quantity and throughput, the volume of the product that can be manufactured in a given time depends on machine speed, manpower, and facility layout. So that is what the capacity of the manufacturing unit, where it can fill 10,000 bottles per hour with a small machine and the technology which has been available. If it is very low means it cannot prepare the 10,000 bottles per hour. So that is one of the what limitation of the manufacturing unit. So all this will be considered. And the plant level limitations, plants are designed for specific industries. As I discussed, automobile plant cannot manufacture medicinal products. The same thing here also, a steel rolling mill cannot process plastic. So that is the technology availability of that particular company. So that comes under plant level limitation. Machine level limitation means the machines are specialized for certain shapes, sizes, and materials. So example, injection molding machine can only produce plastic component of specific mold shape. So it cannot go with the other shape of the bottles, right? So these are some of the limitations which come under the manufacturing unit. The capability has to be initially considered, and then the whatever the orders that will come into the company has to be taken. So what if the company can process those order, then only they have to go move forward for preparing the products, or else the company cannot manage the order, and it may end up with delaying of the product to the market. Mass production. The mass production is a manufacturing process that involves producing large quantities of identical products over a long period of time. So it is designed to meet high demand efficiently and consistently. So example of mass production is what the preparation of smartphones, automobiles, laptops, soft drinks, all will come under mass productions. What is the main features of mass production means the larger volume in which the production can be carried out. A single product or very few product variations are produced in this mass production uh, process, where the production will run continuously for months or even years. High demand. Mass production is economical only when there is a consistent and high market demand. Only when there is a high demand in the market, then only you can go with mass production. For 10 to 50 components, you cannot go for mass production. So when there are multiple more demand, like 10,000 lakh of components that needs to be manufactured, then only the mass production concept has to be taken place by the company. A dedicated manufacturing plant. The manufacturing plant is specially designed for one product. Special purpose machines, automated assembly lines, conveyors, and transfer system. So all will focus on what a dedicated manufacturing plants. One specific product will be one or two or three can be varied, slight variations can be done. So that plant usually focus on the mass productions, standardization. So whatever the product that is being going to develop, it will be fixed and standardized. Components can are interchangeable. Strict quality control ensures uniformity. So all this will be added advantage for the mass productions, low cost per units. That is one of the added advantages of the mass production, because number of components will be prepared, the due to which economics of scales, high production rate, reduced setup time. So all this will leads to the decrease in the cost per items, which has been developed in the mass production. Interchangeability is the process of ensuring that manufacturing parts are produced within specific tolerance limit, so that any part can replace another without requiring additional fitting or adjustments. So it is a cornerstone of modern manufacturing, enabling mass production, easy repairs, and cost efficiency. So the mass production mainly depend upon the parts that is being manufactured in the way of interchangeability. So where whatever the product that you are going to be manufactured, it can be easily replaceable. So example I've given here, all parts of the same types are made to identical specifications. So every bolt of certain size M8 into 1.25 fits into any matching nut. Right. So if any nut or bolt, which is a standardized part, has been damaged, so it can be easily replaced by another part that has been of the same standard size. So interchangeability will be easy, and due to which uh, whatever the product that you're going to develop can be easily assembled as well as disassembled, and can be user friendly. That is what the main intention of the interchangeability. Tolerance control, variations in size are minimized and kept within acceptable limits. A shaft diameter may be specified as 20 mm plus or minus 0.05 mm. Any shaft within this range will fit into bearing. So that specification needs to be controlled in the mass production. So then only this interchangeability concept will be implemented. Easy of replacement. Damaged or owned parts can be replaced quickly without custom fitting. A car spare parts like brake pads or spark plugs are interchangeable across identical models. Automotive industries, standard tires, bolts, and filters can be easily replaced across vehicles of the same models. So these are some of the importance of the interchangeability. When it comes to the product life cycle, what is a product life cycle? So the initial stage to the end of the product, which has been uh, where the product completely what decline, no sales will take place. So up to that, from starting stage to the end stage, we call it as a product life cycle. So the time span between the conception of a product and the point at which it is no longer profitable to manufacture or sell. So that we call it as a product life cycle. It describes how a product moves from through different stages in the market. So there are different stages will come into picture when you consider any of the product you take. So it follows these stages where the product will be introduced into the market. That is launching of the product into the market. Heavy investment in marketing and promotion. Sales are initially low but starts to raise as awareness grows. A new smartphone which has been entered into the market. So initially it has got some attention, and the market, I mean, product has been launched, and the heavy marketing and promotion and marketing will be carried out, and initially the sales will be low. Then afterwards, due to some marketing and promotions, a gradual increase of the sales will takes into picture. So that we call it as the growth stage, where the customers become familiar with the product. Sales increases rapidly. Profits rise due to economics of scales. Competitor may enter the market. Example, electric vehicles gaining popularity and adoption. So day by day, the popularity has been increasing, and the growth rate of the electric vehicle has been increasing. So maturity stage. So sales growth slows down and stabilizes. So once the complete growth stage has been happened, so the maturity stage will come into picture, where the sales will be at some constant level. It gets stabilizes. So yearly, this much of sales will happens. So like the 2 to 3 years, based upon the lifespan of the product, it means the growth will slightly slow down and get stabilizes. So market becomes saturated with competitors. Companies focus on differentiations. So all this will considered in the maturity stage. And last one is the decline stage, where the sales and profit starts to fall. The product may become outdated due to new technology or changing consumer preferences. Company may discontinue the product or innovate to replace it. Example, DVD players. Initially, DVD players you can consider where the when it comes to the market, say gradual rise of the product in the market has been increased, and then maximum sales of the DVD players were occurred, and then gradually it has been declined, so none of them has been using the DVD players, so due to which a new technology has been replaced it. So that's what how a new product development will come into pictures. The product, whatever the product that is there, it follows this all these stages: introduction stage, growth stage, maturity stage, and decline stage. So whatever the product that will come into will be considered, it follows the yes steps. That is what you can just notice the yes symbolic representation of this yes is there, right? That indicates what? The S curve, the S curve of the technology growth cycle, right? So it mainly comprises of slow growth phase, rapid growth phase, and leveling off or mature phase. So what is the importance of the S curve in engineering and manufacturing? Means it helps the engineer to decide when to invest in a technology. So DVD player has been declining. Now that is the right time for the company to focus on the new invention, new innovation, so that a new product will be launched in the market, and that will help in growth of the uh, sale, growth of the sale, and the company will get profit. So avoid wasting efforts on saturated technology. So instead of going with a newer technology, if you go a backward technology of the DVD player, then it is a waste of money and it will lead to the failure of the product. So guides in R&D planning and innovation strategy, supports decision on technology replacement. So all those things will be helped for by going through the S curve of the any product. So design for manufacturing. So what do you mean by design for manufacturing? It is a systematic approach in product development in which a product is designed in such a way that it can be manufactured easily, economically, and efficiently while still meeting functional, quality, and customer requirements. So design for manufacturing is a core element of concurrent engineering where design, manufacturing, quality, cost, assembly considerations are addressed simultaneously during the design stage. That means whatever the stages we have been discussed, right? The design stage is one, the manufacturing stage is one, quality check, cost, estimation. So all forms one of the stages. But whereas in concurrent engineering, the design for manufacturing process, all these stage will be simultaneously considered in preparing the product. If manufacturing issues are not considered during the design stage, it will leads to the high loss of the product. So design changes become very expensive. So quality problem will arises. Production delay will occur. So due to this, the cost of the product will be high. So all these things will be interconnected. So as because it has been interconnected, the initially the design stage plays a very important role where it considered all the stages, all the steps like manufacturing, quality, cost, all this will be considered in the design stage, and it follows a simultaneous process. So that we call it as a concurrent engineering. The major activities that will be included in design for manufacturing is understanding market and user expectation, selecting appropriate design principles and concepts, identifying suitable material and manufacturing process, design analysis and rectifications, meeting quality expectations, analysis of assembly and disassembly, development of engineering models and detailed designs, economic analysis and production cost estimation, prototype development, engineering testing and redesign, design feasibility analysis, production planning, control of production and distribution activities. All this points, activities has been considered in the design for manufacturing. As the name itself indicates, design for manufacturing. Before manufacturing, you're going to go through a thorough design process has to be focused in the product, so that the whatever the product that you are going to manufacture, that will be suitable to what launch into the market with a higher success rate. To get the product to be with a higher success rate, the design for manufacturing principles needs to be followed, and whatever the product that follows the design principle, design for manufacturing principles, 90 to 95% of the products will succeed in the market. That is what the principle mainly focus on. So without DFM, what happens? The complex geometry you're going to end up. tight tolerance everywhere, it will be there. Special tooling arrangement needs to be chosen for preparing the components. High production cost will happen. So these are some of the major concern when you are not following the design for manufacturing principles. When you're going to follow it, so the geometry which you're going to prepare, it becomes simple. The tolerances wherever it is required, you're going to give it, and then the design is safer for its functionality. And use of standard tools is sufficient to prepare the parts. Lower manufacturing cost will be the outcome of following this technology. Engineering problem solving process. The engineering problem solving process is a systematic and logical approach used by engineers to identify, analyze, and solve technical problem efficiently while considering technical and economical and practical constraints. A widely accepted models describe this process in five main stages. So when it comes to the engineering problem solving process, it has been categorized into five main steps. Formulate the problem, analyze the problem, search for alternative solution, decide among alternative solutions, specify and implement the solution. So these are the five major steps which has been focused or accepted model of the engineering problem solving processes. So what does the formulate the problem indicates? It clearly identify and defines the problem, its objectives and constraints, that like cost, time, safety, standards, all will be considered in the first stage. Second one is the analyze the problem, where you are going to collect and study relevant data, understand causes, and break down the problem into manageable parts. And search for alternative solutions means where you are going to generate multiple possible solution using engineering principles, experience, and brainstorming, and decide among alternative solutions. So where you're going to evaluate each option based on feasibility, cost, reliability, and performance, and select the best one. Specify and implement the solution, where prepare the detailed specification, implement the solution, test it, and document the result. So these are the engineering problem solving. So how the engineering problem you are going to solve? What is the process that is involved in solving the engineering problem? Whatever the problem that you have taken, what is the step ways in which the it will be taken, is what this five steps has been clearly identified. So example, high rejection rate of machine shaft due to diameter variation. So this is one of the example which I have taken. So that is the a problem, high rejection rate of machine shaft due to diameter variation. So due to the diameter variation, what is happening? High rejection rate is of the particular shaft is been happening. So you're going to formulate the problem. So what to do? Clearly define the problem and constraints. So what is the problem? Shaft diameter goes out of the tolerance, causing rejection. So that is the problem. You have formulated it. And what is the constraints? Existing CNC machine, limited budget, delivery deadlines. So these are some of the constraints. Based upon this, the output is what you're going with: high rejection rate of machine shaft due to diameter variation. So you're going to analyze the problem. So what to do? You're going to collect the data and identify the root causes. So what is the example? Measure the rejected parts. First, you need to take the parts. What are the rejected parts is there? You're going to measure it. Variation increases after long runs. That means when the part is been number of parts will be prepared on that particular CNC machines, and the diameter variation occurs after some time period, and then the products are being rejected. Check machine. So whether the tool wearing is happening, any vibration is occurring, that review process needs to be followed by checking the cutting parameters unchanged for long periods. So that is a major region. The cutting parameters, whatever the tool which are you going to use, the cutting parameter has been unchanged for long periods, due to which the tool wear and vibration has been happening. So that is the what you are going to analyze. That is the root cause why the part has been going to reject. Now you search for the alternate solution for it. So what would be the solution? You have to generate multiple possible solutions for that. That means you're going to replace the cutting tool at fixed interval. So don't leave for the long periods. So replace the cutting tool for the some interval, fixed interval periods. Optimize cutting speed and feed. Improve fixturing to reduce vibrations. Use better grade tool materials. So all those things are some of the alternative solutions to achieve the lower rejection rate of the machine shaft. So these are some of the alternative solutions, and decide among alternative solutions. So you need to choose which one needs to be given more importance or prominence. Tool replacement plus parameter optimization chosen. So low cost, quick implementation, effective reduction in variation will takes place by this two decision which you are going to take. That is tool replacement and parameter optimization. So instead of replacing whole the CNC machine, new machine, it takes more cost and it takes more time. So a immediate decision which you're going to do is what the tool replacement, and the you're going to tune up the parameters which you're going to which you have chosen, that is the feed speed, whatever it is. You just tune it up and prepare the component, specify and implement the solution. So implement the test and document. So set tool change schedule every 200 parts, adjust cutting speed and feed, monitor the results, and the final result is what you achieved the rejection rate with reduced. So that will be documented and the process will be updated.